Okay, now that we've talked about relative standing, we have a really helpful visual way, which was kind of hinted in the last example I gave you, to visualize relative standing, specifically 5-number summaries. So if you recall, all of this has to do with sample data. And if we're working with sample data, we might have a histogram representing it visually. And when we want to express where the 5-number summary is located in this data set, then we can use what's called a box plot. The box plot itself is this part right here. So a traditional box plot would have all of the data values represented in terms of just the 5-number summary, which, if you remember, that means you have your minimum, the first quartile, the median, the third quartile, and then the maximum. What we have here represented, though, is not a traditional box plot. This is a modified box plot. And the reason why we might have modified box plots is because sometimes when we want to represent all our data, there are some values that are so extreme that we have to establish a standard for identifying what we call outliers. And those outliers we define by the 1.5 times IQR standard. We'll come back to that in a second, but let's just dissect what this box plot is trying to show us. So a box plot is a way to visualize these really important measures of relative standing. So remember we said that the 5-number summary helps us split the distribution into 4 equal pieces. So the first quartile means 25% of the distribution lies below that line. The median means 50% is below. Now the third quartile means 75% is below. So our box plot consists of this box right here, where the middle line is located all along the median. The first line is located along the first quartile, and the third along the third. Okay, so the length of that box, though, the length of this box is called the interquartile range, or IQR. So the length of the box is the IQR. And traditionally, in a box plot, we have these whiskers that go out to a line that represents the maximum and out to a line that represents the minimum. But this is a modified box plot. And when we want to represent outliers, we have to think about, well, how far away from the rest of the data is going to be considered an outlier. And so our standard is if your data value is either less than your first quartile minus 1.5 times the IQR, or greater than Q3 plus 1.5 times the IQR, then we consider it an outlier by this standard. So these dots here that you're seeing represented, those are outliers according to this standard. And when we do that, then we're establishing both of these whiskers now represent what we call the inner fence. So in other words, everything between those two lines is not an outlier. Those are usual values. But everything outside of that is too extreme to be considered usual. This is not necessarily the same as significant values. This is different. Okay? So that's the basic construction of a box plot. Let's look at a box plot in the wild, or actually a collection of them. So I have here this sample set, and what we're looking at is 5 different data sets, okay? So represented by these colors and these different box plots. And each data set is corresponding to a different sample of people, and each of those people in each of those data sets had their cholesterol levels measured, okay? So what we're looking at here then is we have this sample data set of 20-year-olds who had their cholesterol level measured. And we have here our median, Q3, Q1, not the min, but it could be the min, or inner fence. This is not the maximum, it's the inner fence, and this outlier right here would technically be the max. Okay? But for each of these then, we have the inner fences, the middle 3 quartiles, and then possibly some outliers. So something's really important to note then. How do we take this information and then try to reconstruct the histograms? Or what can we glean from the box plots? Well, for one, the box plots can tell you whether your distribution is skewed or not. So, skewness. For instance, if you have a lot of outliers, or if one whisker, so this would be a whisker, is much longer than the other, or if your median value is not straight in the middle of the box part of the box plot, then you have strong evidence that you may have a very skewed data set. In particular, if you look at this data set in particular, the significance of all of these outliers on the right, because we're thinking about things in terms of everything on the bottom of the chart would be left if we're looking at it sideways, then that would mean this is significantly right skewed. And something similar would happen if we had a lot of extreme values on the left, or if the left whisker was extremely long, much longer than the others. Then, what else can we glean from this? We also have, implicitly, a notion of range, right? We can see how much more variation is present in this distribution than in this one. And so if we were to interpret that here, what we'd be saying is there's a lot more variability in the cholesterol levels of 30-year-olds than in 20-year-olds. Similarly, there's less variability in the 60-year-old range. And we still have a notion of center. So the centers here, not only do we have represented the medians, so here's the median, median. We can see how the median cholesterol level rises through the age groups, but also the means. These dots in the middle, these are the means. And so yes, we do get a lot of information from box plots, whether or not they are modified or regular.